So this video, actually, we want to talk about some application about the shift and the rotate instruction. So how we can do that in some application. The first one we already talked about in the previous other lecture video about the binary multiplication. So this one I just quickly review that. So if you remember, when we shift to the left, when we use the shift to the left instruction, so actually we make the value become bigger. So you shift 1 bit, like you multiply 2 to the 1's power. So you shift 4 bit, like you multiply 2 to the 4's power. Because any number we can combine with 2 to the nth power. So for example, 36 equal to 32 plus 4. So we can consider that's 2 to the 5th power and 2 to the 4th power. So in the previous video, we show you how can we simply to do some multiplication using the shift to the left. So even for any other number, you see here we do the 26. But actually you can name any number. We can combine, become the addition between any 2 to the nth power. So that's the first application we show you. So the next one we want to talk about is how can we use the shift or rotate instruction to display the binary value of a hex in the console. So here, let me show you the console like this. Okay, so for example, now we ask the user to enter a 4-byte hexadecimal number. So that's why here we type 1, 2, 3, 4, 5, 6, 7, 8. So then in our console, they will display in the binary. So you see here's 1, 2, 3, 4, 5, 6, 7, 8. So this one thing is we're not using the Irvine 32 library. We just think about how should we using the instruction we talk about for the rotation or the shifting, so we can convert the hex number we read, but we can display in the binary number. So actually, let's think about the algorithm. How should we work on that? So did you remember we always shift, but we shift also including the carry flag. So now when we think about, I have a number, for example, it's 1, 2, 3, 4, A, B, C, D. I want to display this value in the console become the binary. So actually I should start processing from the beginning, right? So you see 1, they display 0001. Then 2 is 0010. So that's why here is we need to start processing from the left-hand side. So actually this one is, how about we think about every time when I move to the most significant bit, actually did you remember they also not only shift, they also, the first thing is they will move to the carry flag. So on the other hand, since I know that's a carry flag, right? So then if the most significant bit move to carry flag, if the carry flag is set, that means I need to display 1. If carry flag is clear, I need to display 0. So on the other hand, can I try to think about using a shift or rotate instruction? I can continue to update the carry flag. But don't forget, I should start from this side to update my carry flag. So which shift instruction should we use? Right, you need to shift to the left, right? Okay, so this one actually you want to use the SHL or SAL. They are mean the same thing. So on the other hand, what we should do is when we have the value in EAX, even originally they are in the hexadecimal format. So when I want to display them into the binary format, I can just think about I display in a string. So then I just need to make my string 1 by 1. They are. So I have that start to move the carry flag. So then using the carry flag value, I update my string one by one. So total, actually, I need to do 32 times. So then my string will be 32 byte. So then when I update one by one, so then at the end I will display like this. So that's our algorithm. So the first thing, that's create one buffer array. That's why we want to display. So like earlier we said we need to have 32 byte. So here is the value you want to display. 1, 2, 3, 4, A, B, C, D, we have that in EAX. So then I need to do 32 times. So here is my buffer array. I want to save that to update the value according to the carry flag. So right, I need to do the shift to the left for 32 times. So that's my L1. So at the end is my loop L1. So every time I just shift one time. So if carry flag is set, so then I just need to have the value in the buffer I assign 1. So that's why if that carry flag set, I jump to L2. So we move the 1 to the ESI. So afterward, the ESI need to increment. But if the carry flag set, I do the 1. So if carry flag is not set, right, so I do the 0. So after we're done, actually we all jump to L3. So that's we all increment ESI, so we go back to the loop. So afterward, after 32 times, at the end, my buffer string will have all the binary display bytes in there. So I can write string in here. So this example, actually, you can download from the demo file. I already have the demo file in module 11. So you can either using the bin to the ASCII value.asm file from your Irvine 32 library from chapter 7. But this one, actually, they only hard-coded for the EAX equal to 1, 2, 3, 4, A, B, C, D. Now, earlier, the demo I showed you, we can prompt to the user to get input. So that one, you can find that from the demo file. So then we can get from the user input. Then we can display the output. So that's the first two applications.